393, 490,
300,
300,
and 1,183,
and then vertically for females
608,
and males.
575.
Thank you. All right, so the first question, we're finding the probability that a student is female given that the student takes physiology. So there's our word given. So let's talk about the number that goes on the bottom. What number are we putting on the bottom of this probability? Maggie, what you put on the bottom?
The number of students who take
Yeah, so the number of students that take physiology, that's the whole group that we're looking at, so that goes on the bottom, that's 300. And then Maggie, what number did you place on the top?
the number of females.
Yeah, the number of females that are in the physiology class, so that's 160 out of 300. What would that reduce to, Maggie? 8 over 15, nice job. So the word given kind of gives us the total information that we're taking the group out of. And then the top number is that number that applies to physiology. So the second one, we have a student is male, given that the student takes biology. So Mackenzie Myers, what do you have for that probability? And that number would be 393. So 393 people taking biology. How many of those are males? 185. Does that reduce? No, does not reduce. The third one says the student takes chemistry. Again, here's the word given that the student is a male. So Connor, what do you have for that one? Student takes chemistry given that the student is a male.
250 over 575, which reduces to 10 over 23.
So 575 male students, 250 of them are taking chemistry. And then the last one just said the student takes bio. What's the probability that the student takes bio? Julia?
393 over 1,183.
So that's just the total number of students taking biology out of the total number in the chart or in the college. So 393 biology students out of 1,183. So that is not a given, it's not a condition, we're just looking at the total of each group. Questions on those 4 problems? So if you look at the next set of problems, talking about in a math class, we have 3 sophomores, 13 juniors, and 5 seniors. So that usually is the mix of my honors sugar pre-calc class. I have a couple of each, predominantly juniors, but we have some sophomores taking the class and some seniors. It says if 3 people are sick, what's the probability that none of those people that are sick are seniors? So looking at the total that would be in this class, well, how many total students are in the class?
8 or 16.
So 16 and 5 make 21. So 21 students in the class. I'm going to pick one student to be sick. Find the probability that that one student is not a senior. So Will, how many students in the class are not seniors?
16.
16. So 16 out of 21 students are not seniors. So find the probability that none of them would be seniors who happen to be sick. So that's one person, but it says 3 people. So now I need to think of that a second time. So that's the probability for my first person. What's the probability that the second person? Melanie?
15 over 20.
Right, 15 over 20. Because now that one person has been identified that they're not a senior, so they're taken off the list, they can't be counted again. Because I've already identified them that they're sick and they're not a senior. So then Melanie, for the third person, it would be 14 over 19. And that's very similar to the first question of the multiplication rule worksheet, which we can look at. So you have 3 different people, you need to do the probability for each person. So the probability for the first person then that person gets taken away. Probability of the second person, the probability of the third person. Melanie, what is that fraction as a reduced fraction?
I said 8/19.
8/19. Questions? So think of it, 3 different people, you have to do the probability for each person. So that number 3 means probability first person, second person, third person. So looking at the marbles, we have 6 green, 8 red, 5 marbles in a bag. You're choosing 2 green marbles and then 1 red marble. And it says when each marble is replaced before selecting another marble. So when you're thinking about this, you're picking a green marble, and then a red marble. So you have to think, like each marble gets its own probability. So really I have 3 marbles that I'm selecting from a bag. Just like the 3 people that we're selecting. So that number 3 represents the number of times I'm multiplying the probability together. So the 2 green gets 1 green, 1 green, 1 red. So Abby, what's the probability of getting a green when I pull a marble out of this bag?
6/15.
How many total green, or how many total marbles are there?
19.
So 6 out of 19. Did you say 19? I just didn't hear you.
I don't know.
So we have 6 out of 19. We're getting that marble. You're looking at it. You're putting it back into the bag. So then what's the probability of pulling another green marble out, Abby?
6/19.
6 out of 19. Again, you look at it, you put it in the bag. And now I want the probability of getting a red marble, Abby, and that would be 8/19. And I don't think that reduces, so when you multiply the top together, so 6 times 6 times 8.
288.
And then how about the bottom?
6,859.
Any questions with that? So when you're doing probability of like multiple things happening, you have to think of each event as a separate piece, but you're multiplying those together. So for the last one, it says choosing 3 red marbles and 2 blue marbles. So really you're finding the probability of getting a red, and then 2 blues. So then we're looking at a blue and a blue. But each marble gets its own separate probability. This time it says without replacing. So Matt, what's the probability of getting a red marble? So then you take that marble out, you don't put it back in the bag, then it would be, and again, you don't place that marble back in the bag, and then it's, so now we want a blue marble, Matt. Right, so I still don't have that marble in the bag. Each time I take one out, I have one less, and then finally one more blue marble, Matt. 4/15. And Matt, do you have a reduced fraction for that?
14/2,757.
Nice job. So again, think of it, each marble as its own separate probability, but you take it out of the bag, it's gone. It's not in the bag anymore, so you have one less marble remaining in the bag to choose from. So that is called the probability where it's dependent events. One event is affecting the change, the outcome, the number of chances for the next event occurring. So if you look at the, let's look at the multiplication worksheet. That was the one you got on Friday. Just looking at the first problem, a manager can identify employee theft by checking samples of shipments. Among 36 employees, 2 are stealing. If the manager checks on 4 different randomly selected employees, find the probability that neither of the thieves will be identified. So There are 4 different people that I'm going to check on. So that means I need to find the probability of the first person, the second person, the third person, and the fourth person. But the fact that none of them are thieves. So if I look at the information, if 2 of them are stealing from me, that's 2, how many of them would not be thieves then? Holly, how many would not be thieves if 2 are? 34. So the probability that if I'm kind of checking samples of shipments, the probability that none of my employees are thieves would be 34 out of 36, if 2 of them usually are. So now I've checked one thing, and I'm not going to use that same person again, because I already know that like that person or that shipment is checked off my box. So then I'm going to go to the next one. So it would be 33 out of 35. So that's the second person not being a thief. Again, once I know one person isn't a thief, I move on. I'm not going to check the same person. And there are 4 people that we are checking on. So 34 of them are not thieves out of the 36 employees. And then once I get that one person marked off, I'm moving on. Questions? And that reduces to 248 over 315. So when you go to look at number 2, in a department store, 120 customers, 90 of them who will buy at least one item. If 5 different customers are selected at random, one by one, find the probability that they will buy at least one item. So you need to do this 5 times for each customer. So the probability that the first person would buy at least one item, Julia, would be?
90 over 120.
Right, so that's the first person. So I'm not going to check that first person again. So then, Julia, the second person's probability would be?
89 over 119.
And then the third person?
88 over 118.
The fourth person?
87 over 117.
And then the last 5th person would be?
86 over 116.
So the probability is changing each time because it's not going to stay the same. I'm not going to ask the same person over and over and over again because then I wouldn't really be getting any information. I'd just be asking that same individual. So every time you ask a person, you're not going back and asking that same person. The reason you have it 5 times is because you're finding the probability of 5 different customers. So each customer gets its own probability. Depending on the calculator you have, the math rack may or may not reduce it, but this is approximately 0.23. If you individually reduce these and then multiply, you'll get a more reduced answer. But those numbers are so big. Sometimes math rack, just because the fraction is so big, isn't going to reduce it. But if you individually reduce them, it would work. It should be about 0.23. So those were 2 of the problems that I saw as I was walking around. Are there other questions on the multiplication rule worksheet that you wanted to go over? Holly? So 3 cards are drawn from a standard deck of cards without replacement. It says find the probability of getting the following. So all of them are queens. So we have 3 cards, Holly. How many queens are in a deck of cards? 4. So the probability of getting a queen, if 1 card is drawn, would be 4 out of 52. So then I'm picking 3 cards, so I pull 1 card out, I place it aside. Holly, what's the probability of getting a second queen?
3 out of 51.
And then the probability of getting a third queen would be 2 out of 50. I'm only picking 3 cards. So that means the probability of each card, each time I pull it out of the deck. So 4 out of 52, 3 out of 51, 2 out of 50. That reduces to 1 over 5,525. So there's 3 cards that I'm choosing, but there are actually 4 queens in the deck. So the first number represents the number of cards you're taking out, so the number of probabilities that you're doing. Other questions? Number 8, multiple choice test allows the answers of A, B, C, D. A student answers 10 questions by random guessing. So you have no clue, you're just going to guess. What's the probability that all 10 questions are correct? So let's just talk about one question. What's the probability that one question is correct? How many correct answers would there be for one question, Julia?
1 out of 4.
Yeah, 1 out of 4. Because there are 4 options, one of the 4 options are correct. Can you have the same answer more than once? You could have a B all the time. You could have a C all the time. You could have a D. So it says, what's the probability that all 10 are correct? So you could do this probability 10 times because it's going to be the same every single time for each question. So this would be question 1. I would do that for question 2, question 3, question 4, and so on. Or I could raise it to the 10th power since the probability is the same for each question. So each question has a 1 in 4 chance of being correct. And then I have that 10 questions. So that would be 1 over 1,048,576. Other questions? So I have a probability review worksheet for you that also includes permutations and combinations in the counting principle. You have 16 minutes. The answers were sent yesterday through Remind and posted to Google Classroom. Please make sure you're checking the answers for yesterday's probability worksheet and for the review worksheet. And if you have questions on yesterday's probability worksheet, I will come around and answer any questions that you have, especially if you were not here yesterday. So please ask questions. Again, check the answers. Make sure you show work for every problem. You'll be asked to do the same thing on the test tomorrow. If you have questions on the probability worksheet, please ask as well.